Okay, so we're back onto this question. Meika, I checked through all of what you've sent me, and everything's really. Ooh, let me connect my thing. So everything's really good. There's a few questions I want to work with you, and I think you got confused with the question or the actual thing, the actual equation. I don't know where you got -9 from, but the idea seems to be correct. Let's go through that one more time, and also question 11c. So here we're given a function, gx is log base 3 of x plus 2 minus 2. All right, so these are the questions we'll be going over. Find the domain and range. So firstly, I want you to think about what a log function looks like, okay? Roughly, a log function without any changes looks sort of like this, right? It looks like this, bam. So now we look at plus 2 minus 2. We know there's original point here. This is 1, 0. And if it's plus 2 minus 2, we're going to shift it left or right. Have a think. Left or right? All right. If it's plus 2, we're going to move it probably to the left, all right? Normally, it looks like it's plus 2 is to the right, but it's actually to the left. So this will move to the left. 1, 2, and then minus 2 down 2. So 1, 2. We'll have a point here at 2, 2. -2, -2. Sorry? Is that correct? No, sorry. Oh my god. That is not -2. This is actually -1. -1 and -2. All right, cool. So there's a point here, -1, -2. And then let's look at the original. Originally, we would expect to have an asymptote here. So now we shifted it 2 to the left. Our asymptote would be, what is this? Have a think. Normally, it's at 0. If you move it left 2, it'll be now -2. Was this a vertical or horizontal asymptote? This was a, that's right, it's a vertical asymptote because it moves up and down, okay? All right, so now we roughly know what this looks like. It will be sort of like this, okay? Great. And we only have this point right now. The rest, the black bit, that's just based on the original expected graph of log base 10 of x, okay? Don't worry about anything else. We're just moving things around, called transforming. So having known that our graph roughly looks like this, the domain should be, and the range should be, the domain should be something, remember it's x, okay? Domain is x, so we look from here onwards, it has to be greater than -2, right? So x just has to be greater than -2, okay? Now, what about y? Does y go up and down forever or not? Have a think. Does it ever stop? No, so y just belongs to a set of real numbers. Great, so that one's done. Any asymptote and axis intercepts? Yep, we've found some asymptotes. The vertical asymptote is -2. Let's think about some intercepts. So when does it touch the x-axis and the y-axis? Let's do it here. So when x-intercept is when y is equal to 0. So 0 is equal to log base 3 x plus 2 minus 2. So 2 is equal to log base 3 x plus 2. And then it'll be 3 squared is equal to x plus 2. Therefore, x is equal to, what do you think that is? X plus 2 is 3 squared. Sorry, I can't do that. 9 minus 2, which is 7. So the x-intercept is at y 7 and 0. Okay? Where is 7, 0? So it'll be somewhere here. So I actually drew that very off. But look, don't worry about my graphs and everything. I'm just trying to go through the algebra with you. Do the same thing for the y-intercept, please. This is when x is equal to 0. Okay? This one's much easier. It will just be log base 3 of 2 minus 2. And you have to put that into a calculator, unless you're superhuman. Great. So we finished that one. Are there any horizontal asymptotes? No. Okay? If you know what the log graph looks like. And because we already answered that y belongs to all real numbers, there is no horizontal asymptotes, as in it doesn't cut off like that. Find the defining equation for the inverse function of g. Yeah, okay, let's give that a go. And d, so let's do the inverse of this one. So to find the inverse, we swap x and y around. So x is equal to log base 3 of y plus 2 minus 2. Okay, give that a go. You have a think about how you move everything across. Okay, the hint is, it's just like before actually, how we solved it. We can just move everything to the other side first before we raise everything to the power of 3. So now it'll be 3 to the power of x plus 2 is equal to y plus 2. Therefore, y is 3 to the power of x plus 2 minus 2. All right, there we go. Let me think. So to verify that this is indeed the inverse, we can actually look at if the domain and range of this one, okay? The domain of the original function should be the range of the inverse function and vice versa. And indeed, if you graph this, it is true. Or you can just look at the answer sheet as well. That is how you verify your answer, by the way. And also the intercepts as well. And finally, sketch the graphs. Now, what I'm going to do now, Meika, is I'm gonna sketch it with the info we have. It'll be a quick one, but you'll see what I want you to focus on. We had the points before. We calculated 0, 7. We know the vertical asymptote here is x is equal to 2. And we found a point before. It was -1, -2. So it should be around here, down here. And it will look roughly like this. Okay. Now, how do we find the inverse? The inverse should have a horizontal asymptote. So this is -2 of -2. Okay. It should touch at, so this is 7. So it should be 7 here. Remember, it's all flipped around. Okay. And instead of this point, which is -1, -2, it should be flipped around on the other side. So it'll be -2, -1, somewhere around here. Okay, and it will look something like this. And if we draw a line across, oh my God, what is this pen? If we draw a line across y is equal to x, we should know that they are mirrored. Okay, beautiful. So that was question 10. Sorry, the working out was a bit messy. I didn't plan that very well. But if you're ever confused, just replay the video again for that specific sub-question we were doing. And if you still have any questions, just send me a message. I'm always available. Now, for question 11C, I think you wrote, from memory, the wrong answer. Let's try doing this together once. I think you just misplaced this specific value. It's at 0.1%. Because you got the rest correct. So let's give this a go. I'll put it over here. We have WT. Okay, whenever you get an equation like this, I want you to think about, oh my God, what is this even? So to read this as a sentence, it is, this equation describes the weight after a certain time, measured in weeks, of a radioactive isotope. So it's just some element. And it's 8,000 times e to the power of negative the amount of weeks over 20, and this gives me the weight, the grams. Okay, so once you realize what the equation is actually talking about, it wants us to reach 0.1% of its original value. What does that mean? In math, oh sorry, why is it not moving? Oh, it's on, there it is. Okay, what does that mean? In maths, when it says to reach 0.1% of its original value, original is 0, right? W0. So 0.1%, that is actually 1 over 1,000. Because 1 over 100 is 1%, so 1 over 1,000 is 0.1%. And that would be WT. Okay, so given this equation, what is W0? Do you know? So when W0, that is when T is equal to 0. What do we get? It is just 8,000, isn't it? Because this would be 0, so it would just be 8,000. Okay, so if W0 is 8,000 times 1 over 1,000, therefore WT, and T is 0.1% of the original. But to be honest, Meika, this is written wrong. T should be in weeks, but in this case, we don't know the amount of weeks. I'm just writing it in this way so you know what we're finding. We want it when it is equal to 8 grams, okay? Keep the units right. So 8 grams, okay? We want to find out what T is when the weight after a certain amount of weeks gives us 0.1% of W. 0. That's a big word, a big mouthful that I just said. But that's all you have to do. You just have to do 8 is equal to 8,000 times e to the power of, okay, I can't memorize it anymore, negative t to the power of 20. Negative t over 20, sorry. And you just solve this. This should give you, let me put this in a calculator. It should be negative t over 20 is equal to ln 0.001. So what I'm doing is I'm just dividing 8,000 across and then moving e across by finding the natural log of both sides. And I should write that down, sorry. T is equal to negative 20 ln. I skipped a few steps, Meika. See if you can catch up. 1. And in the calculator, this gives me 138 weeks, which is the same as the answer. Great. All right. So that's the way you solve both of these questions, okay? Again, I apologize for the working out. If this doesn't even make sense, just let me know, please. I was going to talk to you about some extra homework I wanted you to do. So we finished all 4 review sets. I don't think you've had any major problems. With question 10, I suspect that you got the wrong numbers somehow. Maybe you wrote it down wrong. So see if you can do it after I explained it. In question 11, it is a trickier one because they worded it differently. But there's no major algebra or conceptual errors you have with logs or any other topics. I'm thinking since you're at Japan trip, let's just have no homework this week. Take it easy. Next week, we'll continue on transformations, which is really good because it builds off of the question 10 sort of questions. All right, cool. Best of luck. When you view this video and finish it, send me a message. Let me know how you found it. And in future, I will improve. I will write in neater, in a neater working out form. Plan everything out. Otherwise, hope you had fun at camp and stay safe if you have not gone yet. Bye-bye.